And so here I'm asking you to restrict the function f of x so that it only has the domain 1, 2. The way you restrict the domain is with these curly brace operators. Desmos symbology is to let curly braces indicate logic. So curly braces mean only if this expression is true. This is very much a Desmos thing and not a wider math thing. So I want to restrict it from the domain 1 to 2. And what do these square braces mean? Yeah, this includes 1 and 2. So the visual symbol for inclusion here is a closed dot, which means like, hey, it's really here. So in this case, we're just walking up to it. But the closed dot means it is included. So this is all of the x's that are greater than or equal to 1 and less than or equal to 2. So I've used my curly braces here, and curly braces so I did it. I restricted the domain. Let's now this domain 3, 5. People also use round braces or parentheses, and this is really unfortunate. Why? Like, this is a bad design choice. It's not that it's incorrect. Yeah, this looks like a point. So when you see this, this could mean two different things. It could mean the point located where x is equal to 3 and y is equal to 5. Or it could mean all of the real numbers strictly between 3 and 5. So not including 3 and 5. Does this bother anyone else, that this ambiguity? So it bothers some mathematicians nowadays but the way I express this is x strictly between 3 and 5. And I don't see any graph. That's scary to zoom out. Oh, okay, cool. Thank you very much. Now this isn't quite the graph I want. One thing, it's too thin. Hold your mouse down on this part where it looks like a sine wave. It gives you some options. One of the options is thickness. So if you want to make the line or the curve more visible, you can adjust the thickness here. That's kind of a minor aesthetic thing. There's something here that's really important though, that might be an opportunity for misunderstanding if someone else looks at this graph. The problem is this looks like it goes all the way up to x equals 3. But it doesn't. So how do we make it clear that it doesn't? We don't want someone to fall in the hole. Okay, so 3, and then how do I find the y? Why would it be 10? Yeah, it's where it looks like it should be. So you can see it visually at 310. Are you just looking at it visually? That's totally legitimate. So 310, but then what do you want to do at that point? And then since that was thicker, maybe I'll make this thicker. So you can change your dot setting to be open to show that f of 3 is undefined, that 3 is not in the domain. Desmos knows this, by the way. If you ask it what f of 3 is, it'll tell you it's undefined. So that's good. If you didn't see it visually, you could get that number by saying what the formula would be. So that looks like maybe it's 516, but let's confirm that. Up until this point holds, 3x plus 1 is the law. So where this point should be is where 3x plus 1 would be at x equals 5. So I can plug in, that should be 5 for x, and then the 3 times 5 plus 1, which is 16 for the other one. And now that's much more informative because it tells me exactly where to stop. Do you agree? So be careful with this open versus closed interval, whether or not the endpoints are included. And if they're not included, please make that clear.